Okay, so let's take a look at question 1 on here. If we're trying to find the domain and range of something like number 1, in blue, remember all we want to do, you want to remember that your domain is your x's and your range is your y's. All you're doing is going to each of these individual points and pulling out for the domain the x values and for the range the y values. So like for example, this first point right here, it has coordinate points of -6, so I'm going to take this -6 and make it part of my domain. And I'm going to do that for all of these points. So these 2 points down here, those have an x value of -4. This one right here has an x value of 0. This one right here has an x value of 1. And this guy over here has an x value of 5. And naturally, I'm going to do the same thing for the range. I'm going to go through with each of these points and write down whatever their y values are. So I've got a y value of -1. Right here I have a y value of 3. And down here the y value of it looks like -7. I've got a 2. I've got a -2. And I've got a +7. And that's it for that. So that one's pretty straightforward. Let's move down a little bit and go down to number 4. So number 4, I'm going to introduce something, a little bit of a different concept today on how to think of these things that I think hopefully will help. When I'm looking at a graph like this, it's not as straightforward as that first one because you're trying to find a way to describe every single one of the points that make up this graph. And I mean every single one, not just the ones that fall on pretty points, but the ones that have decimals in there, everything. So we don't want to list all of them. So we need to find a way to describe them. I want you to think of that when I'm thinking about a domain. Think about it like putting up walls to the left and right of this function. Because I'm going against this axis right here, my x-axis. So you want to see, where can I make a wall? I can make a wall right here because there's nothing going in this direction there. It starts right there. If I try to make a wall over here, remember you have an arrow on the end. So I can't really make a wall. When you can't make a wall, that's when we're using that infinity symbol. Now, I'm going to give you a little bit of a different notation than we looked at yesterday. When we looked at this last class, the notation that we used that beginning point, this left wall, as our smallest value, which looks like is -5. And we said, okay, that goes to infinity. I'm okay with you using that for the quiz today, but going forward, I want you to write it more like this. Because I'm saying here that every single x value that makes up this function falls somewhere between -5 and infinity as it goes on forever and ever. Okay? So that's my domain, but now let's look at the range. I want you to think of the range as a floor and a ceiling, where the floor is where this thing begins, the ceiling is where it ends, or the biggest value. Now, kind of similar to domain was, I have a floor right here. There are no points that have a y value below this floor. So that's my smallest value, and that y value is -3. And I'm going to write it kind of similar to how I wrote the domain. And then the same thing that happened with the domain, as I go up and up and up and up and up, I can't make a ceiling. If I make a ceiling, it's going to go right through it. So that's where I'm going to have an infinity again. So let's turn the page and look at 6, 7, and 8. I'm going to keep referring to this as my walls and the range as my floor and ceiling. So let's focus on our walls first. For these ones, you want to make sure you're noting that there's arrows on this. It's going on forever and ever and ever and ever. So there are points down here that have x values that as I go this way are getting a little bit and a little bit smaller, and as I'm going this way they're getting a little bit bigger. Because of that, I can't really put those walls up. They don't work because arrows are going to go through them eventually. So we looked at a couple like this. I'm going to say negative infinity to infinity. Another way to write that, hopefully you recall, is this. All real numbers. So now let's look at our floor and our ceiling. Well, I can make a ceiling right here. And remember, my ceiling is my largest value. So I've got a ceiling of, what's that y value? It looks like it's 4. And this is going down forever. So kind of the same thing with the domain. I'm not going to be able to make a floor because those arrows are going to go right through it. So it's going down to negative infinity. Okay, let's look down here. Number 7. My walls, my floor and ceiling. So my wall, I should have made that red. Okay, oh well. My walls, let's see. I can make a wall right there. There's nothing over here. So that's my starting point. That's my left wall of negative 2. If I go this way, kind of like what we saw in number 4, these are going forever. And they're going to break through any wall that they come in contact with. That's my infinity. Kind of in that same idea, my floor and ceiling. Try and draw a ceiling at the top of that graph. I'm going to go through it, the floor and the ceiling. So this is one that I'm going to have negative infinity, positive infinity, or all real numbers. Okay, and then that last one I asked you to do, number 8. This one has been freaking people out a little bit, but it actually is much easier, I think, than the other ones. Because there's distinct places that x and y values of this graph end. This one you can see really well, the walls and the floor and ceiling. I can make a wall here, I can make a wall here. So my smallest wall value is negative 2. My biggest one is positive, I think that looks like 5. I kind of covered it up. And then my floor and ceiling, I can make my ceiling there, I can make my floor there. So we start at the floor, and we go up to the ceiling. The highest value there, that is 2, 4, looks like 6. Okay? We'll talk more about all this stuff next week. Do not stress too much about this. Good luck on your quiz, and we'll talk next week.